You are very welcome to this demo on how to generate a detailed Splice plan in iNSIDE Desktop. My name is Wilhelm and I work as head of R&D at Hawkeye Computing, the Swedish company developing the iNSIDE network information system. Here we are looking at a schematic view of parts of a fiber network. We have a main site with ID OBG001. We then have splice points such as SP0662 and customer access nodes such as KA04033. Let's also view the customer access node, selected here in the map view. Now we move back to the net view and select the site node OBG001 because we want to generate splice plans from this site node. We select the node, right click and select show, and then show cross connection. The cross connection form for the site node is then shown. Let's select a panel on the left hand side. We select the third one. Now we see information about the sockets in the panel. Let's open information about the cable patched to this socket by right-clicking and selecting Show Opposite Rear. Let's scroll down to socket 61. Here we see information about sockets that are spliced all the way to customer nodes, as depicted by the information about part paths. A part path is a conceptual object holding together the whole fiber route from the site node to the customer access node. The blue background color indicates that this part path ends in a customer access node. We see the customer access node from our previous example here. It is number 61 with ID KA04033. Let's say I want to gain insight into this situation. I want to be able to generate a splice plan for sockets 61 all the way down to 78, and I want to show the information in a single splice plan. Let's generate the information based on real time stored in the system. I select the sockets 61 to 78 and right click and select Generate Detailed Splice Plan. A detailed splice plan is now drawn in real time by the system. Let's wait a little bit while it's generating. It's now opening up in the background in Visio. Let's zoom in. If you prefer, you can also generate the splice plan as a PNG image. Now we see that the detailed splice plan has been generated for us in real time based on the information stored in the system. The splice plan contains information about sockets, socket types, fiber part, splices, splice points, cables, and customer access nodes, and so on. We see, for instance, that the sockets in the panel are spliced to a 96 fiber cable. Let's rotate the cable description so we can see it a little better. Here we see the cable ID, the cable type, and the cable length in meters. The fiber parts are then straight patched through the first splice point SP0653. The text OP1275 denotes that the splice point is placed inside an opto-well with this ID. In the next splice point, SP0654, we see that fiber part 61 is patched to the fiber part 25, for instance. Note that the destination report contains optimizations for readability where it is possible without loss of information. For instance, the sockets 66 to 72 are compressed because they are patched together and are free to be used in the future, as we see, because they end here in the splice point SP0662. These sockets can be used if we receive add-on installations for newly built homes in the area, for instance. Now let's look at our example socket number 61. See how it is patched through several splice points all the way down to a multiple nodes symbol. The multiple nodes symbol is used to display a group of close located customer access nodes. Let's rotate the description of the first one and move it out. We can see that it's the one from our example, KA04033. We see the customer access node ID and the installation address. In a similar fashion, this single splice plan contains information about all the sockets we selected in the panel in the cross-connection form, namely the sockets number 61 to 78. If we would have wanted, we could have generated a detailed splice plan for the complete panel, even though it is usually better to focus on certain sockets of interest to improve the readability. But just to show you the capability of the system, let's generate a detailed splice plan for all the sockets in the panel. So I go back to the cross-connection form, I select all the sockets, right-click and select Generate Detailed Splice Plan. The result is opening up in the background. It's doing a little bit of work for us. So, look at this. Could you imagine how much work it would have been to draw this by hand and to maintain it. If you have a printed splice plan somewhere on a disk drive in a project, it is very often the case that it was old and has not been updated to reflect the network changes. But by using this system, you can generate even very complex reports without the necessity to draw the reports by hand. But even better, you can only extract the information you really need, as we saw in the example where we selected sockets number 61 to 78. So now you have seen a little bit of the capabilities regarding the detailed splice plans in iNSIDE Desktop. These splice plans can also be generated in the web client, which we will show in another demo. Thank you for watching.